Welcome to section 07. Today we're going to talk about congruent and similar figures. Only got two vocab terms for this section. First one is congruent, and if two figures are congruent, that means they have the same size and same shape. The second vocab term is similar, and that's figures that have the same shape but are not necessarily the same size. So there's a slight difference between the two. Congruent figures, they're not only the same size, but they're also the same shape. So the sides are all the same, the angles are all the same, everything is the same. They're two identical figures. Similar, they might be the same shape, so we might have a small triangle like this, and then another large triangle here. So these triangles would be similar if the angles lined up. Okay, so congruent means they're the same size and the same shape. Similar means they're different sizes, but they're the same shape. Okay, so the first thing we're going to be working on is congruent statements. So the corresponding parts of two congruent triangles are marked in the figure. So we've got this triangle here and this triangle here. And you see that they're marked. So like the side that's got one side or one line through it is going to be congruent to the side over here that's got one line through it. Same thing with angles. One arc goes with one arc, two with two, three with three, and so on and so forth. And they want us to write a congruent statement for the two triangles. Now, in order to do that, we have to list all of the congruent parts first. Okay, so if we start with the angles, okay, I want to know what's congruent to angle A. Well, angle A has three arcs to it, so if I go to the other triangle and find what's got three arcs to it, it would be angle D. Same thing with angle B. B's got two arcs in it, so does angle E. Now the final angle, if you'll notice, I can't label it as just angle C, because angle C doesn't really exist, because C is in the middle here. Any four of these angles around it could be angle C. So to label it, I'm going to use 3 points instead. So if I want this one here, I use angle ACB, or I could use BCA, it doesn't really matter. Okay, that's got one arc in it, and the other angle that's got one arc in it is the other side of C, so I would label it DCE. Okay, or if we did ECD, that would be the same thing as well. We also have side lengths that are congruent. So if we take side AB, it's got one line through it. Over here, we have side ED. And again, the order doesn't really matter. I could have AB or BA. The next side, AC. AC has two lines through it. So over here, this one that's got two lines through it is DC. And then finally, side BC has got three lines through it. The side in the other triangle that's got three lines is CE. So that is just listing the congruent parts, but they want us to list a congruent statement. And so for that, I have to list the triangles. So first of all, I have to name one of the triangles. So if we do this bottom one here, I just list it in any order that I want. I could say ABC. Okay. Now when I go to write the other triangle, I have to make sure that I go in the same order. So I have to figure out what angle corresponds with A. Well, the angle that corresponds with A is D in the other triangle, because three arcs to three arcs. B was the second one I used, so two arcs. I got to go to two arcs in the other one, that's E. And then C has one arc in it, so I'd go back to C as well. So that is my congruent statement right here. We're saying that the triangles are congruent by naming them. Okay, the next one, we're determining similarity. We're determining if the polygons are similar or not. Now remember, similar does not mean that they're the same size. It just means that they're in the same shape. Okay? Now shape is usually determined by angles. So if we look at our two shapes here, I've got one of them's got 90-degree angles everywhere. The other one, as you can see, does not. So since our angles are not the same, means that they are not similar. Okay, if the angles were the same, then we could go and look at the sides. Okay, so let's assume the angles were the same, we would look at the side proportions. So 4 and 3, 8 and 6, 8 and 6, 4 and 3. If all of these were equal, which they are, then it would be similar. However, since the angles are not the same, it is not similar. Okay, so now we're going to solve a word problem using similarities. Okay, so the city of Mansfield plans to build a bridge across Pine Lake, and Pine Lake is there in blue. Use the information in the diagram to find the distance across Pine Lake. So what I need to do is I need to separate these two triangles. Okay, so I'm going to have a triangle ADE here, and then the smaller one is going to be ABC. Okay, now these are 90-degree angles, and A has to be congruent because it's the same angle in both. So since two of the angles are already the same, I can assume that the third angle is the same. E and C are equal because they have to add up to 180. So if two are already the same, the third one has to be congruent as well. So the sides that I know this side is 100. I know this is 55. Now AD, if you'll notice, is 100 and 120. I need to add those together to get 220. And I'm looking for length DE. So what I do is I can use a proportion. If I use the corresponding sides, 100 over 220, that should be equal to these corresponding sides, 55 over x. And to solve that, I would cross multiply. 100 times x is 100x. 55 times 220 is 12,100. Divide both sides by 100, and I get that x is 121, and we're using meters. So that's how we would use similar shapes to find missing side lengths. We can write a proportion using congruent sides, set them equal to each other, cross multiply, and solve for our variable.